Hi, this is JoJo Maths. Now we can see the example 2 of our chapter 1 real numbers. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. Now in order to prove this statement, we have to consider any two positive integers. Now we can consider those positive integers as a and b. That is, let a and b be any two positive integers. Now we are going to assign the value of b as 2. We are only considering two positive integers a and b. Only for b we are going to assign the value as 2. Since we are having in our equation the integer 2, we are just considering this b value as 2. Okay, now what we are going to do is we are going to apply Euclid's division algorithm to these two positive integers a and b. That is, apply Euclid's division algorithm to a and b. Now we can recall the statement of the Euclid's division algorithm, that is, which implies a equal to b into q plus r, where this r should be less than the divisor b and it should be greater than or equal to 0. Let us take it as equation number 1. Now we are going to substitute the values of a and b value is 2 in this equation number 1. Then which implies a equal to, instead of b we are substituting 2. So 2 into q plus r, where this r should be less than our b is 2 and it should be greater than or equal to 0. Let us take it this as equation number 2. Now here in our statement it is given that q is some integer. So here this integer q is some integer, that is, which implies q must be either greater than 0 or equal to 0. Okay, now what we are going to do is we are going to consider this inequality in order to prove our given statement. Now we can consider this inequality, that is, r should be less than 2 and it should be greater than or equal to 0. What we are going to do is we are going to split this inequality into two parts. Okay, first one is this one, r should be either greater than or equal to 0. Then the second part is r should be less than 2. We are considering this one as first part and r should be less than 2 as second part. Okay, here we can split it in two ways. That is, first part is r should be either greater or equal to 0. That is, which implies r is either greater than 0 or r is equal to 0. Now our second part, that is, here second part is r is less than 2. Now we are going to split this again in 3 cases. Okay, we are going to write this in 3 cases. That is, first one is case 1, that is, r is equal to this one, r is equal to 0 as our case 1. What happens if r is equal to 0? Then that is, case 2 is r is greater than 0. Then our third case is what happens if r is less than 2. So here in this inequality, that is, r should be less than 2 and it should be greater than or equal to 0. We are splitting this inequality in two parts. That is, first part is r is either greater than 0 or r is equal to 0 and the second part is r is less than 2. Again we are dividing this in 3 cases. That is, r is equal to 0 is the first case, and r should be either r can be greater than 0 in the second case, and case 3 is r is less than 2. Now what we are going to do is we are going to substitute. If r is equal to 0 means we are going to substitute this r is equal to 0 in our equation number 2. So what happens? Equation 2 implies a equal to 2 into q. Instead of r we are substituting 0 means then a equal to 2q. Our equation becomes a equal to 2q. Okay, now what we are going to do is we are going to substitute the values for q. We already know q is some integer and also it is greater than or equal to 0. Then means our q value should be 0, 1, 2 and 3, 4 and so on. Okay, so we are going to substitute these values of q value in this equation. Then which implies a equal, if suppose q equal to 0 means then our equation becomes a equal to 2 into 0, which implies 0. If q equal to 1 means then a equal to, substituting q equal to 1 in this equation, so a equal to 2 into 1 which equal to 2. Then if suppose q is equal to 2 means then substituting q is equal to 2 in our equation, then it is a is equal to 2 into 2 which is equal to 4, and it goes so on. Now we can proceed with our case 2, that is r should be greater than 0. Now r should be greater than 0 means it is an positive integer which is greater than 0. We can conclude from this. But we have another one condition in our case 3, that it should be less than 2. Here we can compare these two cases, case 2 and case 3. R should be greater than 0, also it should be less than 2. Then obviously r must be equal to 1 only, because r should be greater than 0 but it should be less than 2 mean the only option is r must be equal to 1. So we are going to substitute this r is equal to 1 in our equation number 2. So which implies a equal to 2q plus r value is 1. Now what we are going to do means the same way like case 1 only, we are going to substitute the values for q in this equation. We know q values can be 0, 1, 2, 3, 4 and etc. So substituting q equal to 0 in our equation means what it happens, a equal to 2 into 0 plus 1 which is equal to 0 plus 1 equal to 1. If suppose q equal to 1 means then a equal to 2 into 1 plus 1, that is 2 plus 1 equal to 3. If suppose q is equal to 2 means then our equation becomes a equal to 2 into 2 plus 1 which is equal to 4 plus 1 equal to 5, and it goes on. Now we can consider our case 3. R should be less than 2. Less than 2 means we know either r can be equal to 0 or r can be equal to 1. That we have already proved in our case 1, r is equal to 0, and in this r is equal to 1 in our case 2 we have proved. So here we have nothing to prove in case 3. We have already proved those steps in our case 1 and case 2. So by comparing this case 1 and case 2, we can conclude that we can see the values of a here. We can compare the values of a in this both case 1 and case 2. Here see a values are 0, 2, 4 and it goes on. Here, so if you see here the values of a are 0, 2, 4, 6, 8 and it goes on. Okay, if you substitute the values of q for 3, 4, 5 etc., if you substitute also we get only even numbers. See this, all are even numbers, 0, 2, 4 all are even numbers. So we can say here these values of a 0 to 4 no even numbers no, here the a is in the form is 2q. So we can conclude that any positive even numbers is of the form 2q. So we can conclude that any positive even integer is of the form 2q. Here a values are 0, 2, 4 and it goes on. If you substitute any values, that is here we have substituted for 0, 1, 2. If you substitute for 3, 4, 5, 6, 7 also, we get only even numbers. So we can conclude that any positive even numbers is of the form 2q. Now we can come to case 2. See here the values of a are a is equal to 1. Here a is equal to, if q is equal to 0 mean a the value of a is 1. If q is equal to 1 means the value of a is 3. Here 5. And if you substitute, now we have substituted the values of q for 0, 1, 2. If you substitute for 3, 4, 5 etc. means we get only odd numbers. Here all are odd numbers, positive odd numbers. 1, 3, 5 all are positive odd numbers. Again if we substitute the values for q, that is 3, 4, 5 etc. also, we get only positive odd numbers. Here the value of a is in the form a is equal to 2q plus 1. So from this we can conclude that any positive odd integer is of the form 2q plus 1. That only we have to prove in our statement. So hence proved. Thank you.